Problem 9.22 from your textbook says draw a structural formula for the product of each SN1 reaction. Where the configuration of the starting material is given, show the configuration of the product. All right, well, let's take a look at the first one. They are telling you it's an SN1 reaction, meaning it's a nucleophilic substitution. What that means is that you will substitute, that means you will replace the leaving group with your nucleophile. And when you have a nucleophile that has just like a hydrogen here, just a quick way to think about this without going through the reaction mechanism is that you can pretend that it does not have that hydrogen there. And you will identify the leaving group. In this case, when you're using haloalkanes, is the halogen. That the halogen is your leaving group. And you will draw it just the same. And keep in mind the configuration is shown here, is indicated. So what you will do is, because it's an SN1 reaction, you will have a racemic mixture. So one will go up and the other one will go down. And this is your nucleophile. So oxygen, and you have 2 carbons, so 1 and 2. Oxygen, 1 and 2. And you will have that HCl as a byproduct of this reaction. This hydrogen is coming from this hydrogen, and Cl is your leaving group. Let's take a look at the second reaction at B. So for B, what we have here is that we identify the leaving group, and keep in mind that for SN1 reactions, the rate determining step includes the formation, or is the formation of the carbocation, meaning that whenever you have a carbocation, keep in mind that a rearrangement is possible. But in this case, this is a tertiary, so you will have a tertiary carbocation, so no need to rearrange. And this used to be the location of the leaving group, but now you will put, again, your nucleophile. You can take away this hydrogen. The hydrogen will go away along with the leaving group as HCl, and you will have oxygen and CH3. Okay, let's take a look at the next one. Okay, now this is also tertiary haloalkane, so no need to do rearrangement. You want to look out for the rearrangement when you have a secondary carbocation to see if it's possible to do that rearrangement. If you want to see it better, go ahead and show the line formula. This is the line formula for the nucleophile. Keep in mind that you are not adding this hydrogen. That will show up here. Cl, I got that from the leaving group. And they used to be the location, this carbon, of your leaving group, but now you will have your nucleophile. This. Start here. Oxygen, double bond between the carbon, the oxygen, and the CH3. CH3. Okay? The last one. We have now to just replace the halogen with your nucleophile without the hydrogen. And you can see why we're not including the hydrogen in the reaction mechanism. When you go over even the generic reaction mechanism for the SN1, you will C. And we went over that for question number 2 of this problem set. The configuration is shown here, so you just include that as well. For SN1, we have a racemic mixture. So you don't have to draw the other one, you can just write racemic mixture. And that is good enough for me at this point. Now we have oxygen. Again, this is your nucleophile, oxygen and CH3. As a product, you will also get the HBr.